Good morning, everyone. My name is Emily Adams. I am the Business Development Manager at Minoxidant. Today's webinar presentation is going to be a little different than usual. We've received quite a bit of interest in dust collection, so we've decided to rebroadcast a previous webinar that covers this topic. We still encourage you to send in your questions, and they will be answered at a later time by a member of our support team. So let's get started.
My name is Tim Elsner. As previously said, I am a accounts manager for Donaldson Torit. I've been working for Donaldson for over 7 years, strictly on dust collection, and have a nice presentation today on the basics of filtration and dust. So we can get started. Our agenda is kind of what is air filtration. Let's start with the basics. What is it? And we'll talk about some of the methods of how we filter dust, or how Donaldson Torit will filter dust, some definitions and examples, a little bit on immediate options, and then questions. And I think we're free to ask questions and answer those questions during the presentation. So the first question is, what is industrial filtration? Well, basically, you've got a process making dust of some sort, whether it's a wood shop creating or sanding pieces of wood, or a welding shop welding and capturing that smoke or fume that comes off of that particulate, off of that process. What we do is we basically capture the dust at the source as best we can. We convey that dust through pieces of ductwork, and then we collect it in what we call our dust collector, and the fan is at the end on the clean side, typically pulling the negative that allows us to capture and convey that particulate. There are a lot of different avenues that create dust. More specifically for you guys, I think it's mostly woodworking, school shops, welding, that kind of stuff. But all the same concepts, just a little bit different depending on what the dust really is. So why is it important? Here's a list of things that most customers of yours are going to look at and say, yep, these are the most important things. Being a company that handles dust, our main priority is making sure that we have a safe product for your customers to use to ensure that their workers are safe while they're getting their product built or made. So this list, though there is 5 on there, it could grow. The priorities change depending on who your customers are. But the big things, again, are making sure that those employees are safe, making sure that OSHA's happy with you and allows you to keep working, making sure that the EPA is okay with you dumping air outside, whether it's clean or dirty. Combustible dust concerns, which I'm sure many of you have heard of, but don't have a lot of experience with. NFPA comes to mind as an acronym that you probably heard. That could be an entirely different presentation just on that, but those are concerns that people are having more and more. There's more and more emphasis on it from OSHA and from other places that are causing us to take action and take action and add things on that would make it comply with NFPA or with OSHA. Last thing would be product quality. I mean, everybody wants a piece of equipment, because at the end of the day, they want it to last. This is a large capital expenditure. They want to make sure that they're getting their bang for their buck. So, where do you see it? I kind of touched on this a little bit, but we can go anywhere from abrasive blasting to pharmaceutical dust to welding, woodworking. We're all over the place, and dust is all over the place. I mean, there are multitudes of customers that we have in different avenues of the world, from making the tables that you're sitting at to the ceiling tiles that you have above your head. So we touch a lot of different industries, and we have expertise in those as well. So how is it done? How do we do this in order to capture the dust and get it safely contained and do something that we can dispose of or reuse depending on what that is? Well, we create that dust through the process, whatever the manufacturing might be. We then create a negative off of the fan, which then pulls the dust from its source through the ductwork to the collection or the collector itself, and then is moved or cleaned off the filters or whatever we're using to capture the dust and put into a container that you can dispose of or put back into your process. If it's a precious metal or something like that you want to keep, we'll put it back in the process and you can reuse it and save that money. Dirty air typically stays on the outside of a filter. The clean air passes through and then is discharged out the fan discharge. So if you're in a climate like I'm at in Minneapolis, we like to keep our BTUs inside and not have to reheat that air or recool that air. So a lot of times people will recirculate air back into the building. If you've got a toxic material or something like that that you don't want to, you dump that back into the atmosphere. So it depends on what you're doing there. But the main thing is we're taking that particulate from a place that you don't want it to be and concentrating it in our collector so that we can dispose of it or do what we need to keep things clean and tidy. Cleaning mechanisms. There's 4 different types up here. For the most part, there are others, but we typically focus on these 4. The main one that's kind of the beginning of dust collection was mechanical separation. So whether you went through a dropout box or a cyclone in the case on the far right, mechanical separation is just dropping that stuff up, putting it into a large cavity that lets it settle and falls out. Then you move into shaker style, which is kind of the next style of dust collection. It has bags typically that you would use. You would put you'd put the air through the bags, and then it would be an intermittent process so that as the collector runs, it would collect the dust on the outside of the bags. You would need to shut down in order to shake it and clean it. So those of you familiar with our Unimaster, that's exactly what it does. It runs for, say, 4 or 8 hours. The guy goes over, shuts it off, it shakes, and drops the dust down in the container, and then you start over again. The other 2 would be a pulse cleaning system. So this would be if you had a 24/7 operation, you need to run at all times. We would run pulse cleaning. So this runs a blast of compressed air to back flush the filter and knock off whatever is on the filter while it's running. And you would have additional filter media around it so that when that filter is being back flushed, you're still pulling air from the other ones. And that would just be a continuous base. It would continue to clean as much as it needed to or all the time, depending on how you had that set up. The last one would be draining. So I don't know how much mist collection you guys do or any at all, but we also have coalescing filters. So they're a glass media, and they don't do anything but just allow that mist to have a place to gather. And then as those droplets get bigger and bigger, they fall down and drain to the bottom. So another list that could be changed depending on who your customer is and what their importance is how do you collect or how do you select a piece of equipment? It might be footprint. I need a very, very small collector because I don't have a lot of room in my shop. Very simple. If I'm taking that up with a dust collector, I can't put a piece of equipment that I can make money at in that spot. So footprint becomes an issue. Filter life, obviously, how many times do I have to change my filters in a year or 2 years so that I know how much capital I have to put into that? Because let's face it, dust collectors aren't money-making machines. They are something that are necessary, but they cost people money. So we want to make sure that we keep that cost to the minimum as much as possible. And you can look at efficiency. So if I'm dealing with really, really big pieces of wood, my efficiency doesn't have to be as high as if I'm collecting stainless steel smoke from a welding process and I'm worried about hexavalent chromium coming out and being a toxin for my employees. So efficiency is also something that might be a priority. And last and probably the biggest one is energy savings. So I don't want to put a collector out there that's going to run a 50 horse fan when I only need 20 horse and I'm constantly using that 50 horse and draining money out of my pocket for no reason. So having a good idea of what I need and exactly what I need will help me keep my energy consumption or keep money in my pocket at the end of the day. So things to consider when selecting these, I would say the biggest one right off the bat is how is it generated and what does it look like? And is it toxic? Because if it's toxic, there are things that we want to do a little differently than if it were just a standard dust. And the reason is if I've got a worker next to a process that has toxic dust, I want to make sure I evacuate that breathing zone so that he or she is not affected by that toxic dust. Also, is the dust combustible? I know we talked about this a little bit with NFPA, but that is becoming a big, big emphasis, and people are seeing that more and more as we need to know what that dust is, what a KST value or a Pmax of that dust is so that we can handle it appropriately and make sure that OSHA is satisfied with what we're doing. Other things would include temperature, because that can affect what kind of media we use. The density of the dust, so if it's really, really light, typically it'll stay suspended over a heavy, heavy dust that'll just fall right out. It's pretty easy. You've also got the loading is what we call it, or how much dust are you throwing at it. If I've got a welding process where one guy's doing 5 minutes of welding and 30 minutes of fixturing, that's different than if I got 5 guys welding for an hour at a time and throwing a bunch of fume at me versus that 5-minute little period of time. So how much am I going to see? And then moisture or oil, because that is a huge problem in a dry dust collection system, because that'll make things sticky, make things messy, make things clump up and cause problems. So understanding those things will help you pick the right collector and make sure that your customer's happy at the end of the day. Lastly, the other things to consider would be control panels. Do I need a motor starter? Do I need a differential pressure gauge? Do I need a VFD to help me with my energy savings? Along with that would be a discharge device. So do I just use a 55-gallon drum? Do I use a rotary airlock, a screw conveyor? What is my customer going to use in order to evacuate this dust? What a lot of people will see, they'll just close a slide gate on the hopper and they'll let it fill up until the collector's full, and then they'll open it up and figure out how to get that stuff out of there. That's all well and good, but your collector's going to suffer because there's no place for that air to go. There's too much dust in there, and you're just overwhelming those filters and causing shortened filter length because of it. So understanding your discharge and how that fits in is as important as the collector itself. Ducting and fans, you know, where am I pulling the dust from? Where am I putting my collector? And where am I safely putting the fan and the discharge of that fan so that either I'm saving money by putting the air back into my building, or I'm dumping it out because I don't want my workers to get exposed or overexposed to what I'm collecting. The last thing would be valves. I believe that's, you know, talking more on the discharge side of things, but it could also be on the combustible dust side of things, where we're talking about isolation valves on the inlet and the outlet so that we don't have propagating flames going back into our building, that kind of thing. Now we're going to move on to filtration mechanisms. Good so far? Yeah, great. So we look at filtration in 4 separate ways. I believe everybody knows how a colander works. You cook your noodles at night, you put it in a colander, you shake it out. The big stuff stays, your noodles stay out on top, and the water falls through. Sieving is the same way in that aspect. So we're taking big particles and we're putting it through a colander, for lack of a better term, in terms of media. Interception would be as a particle is moving through, it would then get picked up by a fiber that we have and just kind of hang out there. Inertial impaction is I've got a car running 60 miles an hour and it hits a brick wall. That car is going to get stuck to that brick wall. That's basically what that inertial impaction is. I'm taking that mass and I'm forcing it into that media, and it's going to stay there. The last one is called diffusion, and really what that handles is the very, very fine particulate, something in the 0.3 or less range in terms of a micron size. And really, it's just attracted to larger fibers or larger masses. And so it diffuses itself and actually wants to hang on to something bigger, and that's what you see here. We've got a couple charts. The first one here is the efficiency versus particle size. As you can see, diffusion, which is that small particles, very, very efficient on the really, really tiny stuff. As it gets to the bigger stuff, we're not collecting that big stuff. It's not attracted to the fibers because they're about the same size. And you can see that all the other ones typically go higher on the larger particles and lower on the small stuff. But altogether, you've got a curve, I don't know if you can point this out, right here, that shows the overall efficiency of that entire mix of all four mechanisms. So there's kind of a jump down in the 0.3 micron range. We consider that to be the most difficult particle size to collect. And if you look at HEP filters, they are rated at 99.997 at 0.3 microns. That is their size that they rate, and they are tested to every time. The reason for that is because it's the most difficult size to collect. Okay, the next one takes that to the next level. It just shows, again, there's a dip. At that 0.3 micron range, where we're in between diffusion and inertial impaction and interception, we have a little bit of a lull where it's the most difficult to collect just based on physical properties. So again, when we test those HEPAs, they're going after that most difficult dust to ensure that when I put that into your factory, it's going to work. So I like this picture a lot. This shows just salt, very, very small salt from 0.001 to 0.5 microns in size. What you see is our nanofiber on top of a substrate. And what looks like crystallization on there is the salt that gets diffused or is attracted to our fibers. This fiber is submicron in size, but it is large enough that it will diffuse with the other smaller pieces, and they will continue to grow like little crystals on the outside of it because they're attracted to one another versus just being free out in space. So I like to use this one because it really shows that any of these particles could fall through these holes. But they don't because of the active diffusion and their willingness to go after larger fiber sizes and just stay there. So here's a quick reference chart. I mean, I think if you Google this, you'd find it. But really, it shows the different sizes of common particulate. If you're looking at tobacco smoke, that's anywhere in the 0.1 to 1 micron range. What you'll also notice is that the visible to the naked eye is typically around 50 microns and larger. So even though tobacco smoke is below that, we're talking about the particulate versus what you can see. So as it gathers together, you can see it, but the actual particulate is small enough that if you were to separate it out, you wouldn't be able to see it. Other ones you might see are just sand, virus and bacteria are on there, as well as human hair, that kind of stuff. So it gives a range of sizes that you might come in contact with if you're doing dust collection, which is what we're talking about today. This slide is going to show you the media itself. So how solid that media is, or how tightly packed the fibers are that I put together. Now, you wouldn't think that this would be a big deal, but Donaldson Company is a filter, or is a media company first. So we have scientists that look at these things all day long. And the biggest thing is they're trying to optimize, should I pack a bunch of fibers in one little spot, or should I kind of spread it out? And the benefits of spreading them out is it's easier for me to pull air if I have bigger holes, right? If I suck through a big straw, it's really easy to breathe. But if I run a marathon with a coffee straw, it's not going to happen. So the resistance associated with tightly packed versus loosely packed medias is what we deal with on a daily basis. Now, with that, what you'll see a lot of people, including ourselves, have is a nanofiber or a melt blown or something as a surface treatment to that media to allow you to have breathability out of the substrate or the base media, but then putting a layer. In our case, it looks kind of like a spider web. That's the easiest way to describe it. And in fact, our Asia counterparts call it spider web because that's just what it looks like. But you can see here, this is roughly a 50 micron particle, so this is right at the edge of what you can see. And because of those nanofiber web going through, there's no place for that to go because it is the holes are so much smaller Even though our breathability stays the same with the larger substrate, the surface loading characteristics of a nanofiber on the top really keeps everything efficient and easy to clean because it stays on the outside. Okay? So what is nanofiber? Basically, you're taking that bottom media, that base substrate, and you're laying over the top, on the dirty side, a nanofiber so that you're reducing the size of your pores, but not hurting your overall restriction through that piece of media. So we can keep high flows, low pressure drop, and very efficient medias with this. And with that, we also get surface loading. Surface loading does two things for us. A dust cake is the best filter you can have. So if we can maintain a dust cake on the outside of a filter, we've just become that much more efficient for our customers. Once we have that dust cake, it becomes more and more difficult to get air through. So when we clean that off, that dust cake is more readily able to fall off because I'm not embedded inside the fibers of my media, but rather on the outside surface. So overall, I get more efficient even with the dust cake, and I get better cleaning, which is better filter life. This is a great shot of it on the side. Basically took a slice of it and took a picture of it. So you can see that the large substrate, the large fibers are here, and that the nanofiber layer, what we call our UltraWeb, is laid over the top. Again, what that does is that keeps the dust on the surface, on the dirty side, and allows the airflow to come through nice and easy through the substrate without restricting it a lot. So, biggest thing, efficiency and cleanability. That's why we use it. That's why everybody has a flavor of it, because it is very, very effective and very, very cost effective as well in terms of filter life and efficiency. We've put together this kind of chart that goes through some of the things you might see in a dust. If you hear my dust is hygroscopic, that means it'll take on water. My dust is abrasive, that's self-explanatory. It'll eat through things pretty quickly. It's fibrous. If it's agglomerative means that you can pack it into a ball and it'll stay there, kind of like a snowball. But you're looking at all these different characteristics to try to figure out the best media, the best collector, the best way to capture that dust and get it out of your system the most effectively. So those are kind of some of the things we talk about. The next slide will show you some photos. These are under a Spectron electron microscope, or I think I messed that up, but anyways, you're taking, say, a fibrous dust on the top. You can see the strands there. You can see an abrasive dust. Some of you might not think it, but that could be sugar that somebody's collecting. If you look at sugar under a microscope or salt, very, very abrasive. You wouldn't think that. Sugar seems harmless. I mean, I love sugar, right? But it is a very, very abrasive dust. The last thing, I don't know how much you guys get into thermally generated stuff other than the weld fume, but this is actually thermal spray dust. And as it comes out, what they do is they heat it up, they basically turn it into molten metal, and they spray it onto a piece of equipment. Well, what happens when they spray it is those droplets turn into spheres. And those spheres are what we collect. And those spheres are actually one of the most difficult to collect because they can pack really, really well together in a dust cake. Or, and as that dust cake packs, harder and harder to pull that dust through. Sorry. So from that perspective, the spherical dust is actually one of the most difficult out of the group to collect. So just giving you an idea of different things that we see from a dust side and how we interact with them with our own equipment. Probably more familiar for you guys would be wood dust. So we can go anywhere from a guy chipping it to a guy taking a time saver and sanding thousands of pieces of wood down a day. So again, you're looking at fine powders in the sanding piece of it to big fibers on the chipping piece of it. So that can also play into how you size and how you select the collector that you use. So real quick on media options, I didn't spend a lot of time on this, but all these filters, all of this kind of stuff, and this is a terrible picture I see, cartridges, bags, pleated bags, we've got power core. There's all different kinds, shapes of filter medias that fit into different boxes. And the reason for that is because every application, you know, from pharmaceutical to woodworking to mining, has their own specific needs. And so what we've done is tried to match those needs more effectively to ensure that the customer is getting the right product at the right price, and they're getting the quality they would expect for that marketplace. Okay? So with that, I think that's it. I haven't seen any questions come through, but I'm definitely open for any questions you guys might have.
That concludes today's webinar on dust collection. Please contact our support team for design assistance, quoting, or any other requests. Please remember our website, minoxavent.com, is home to a complete catalog and various other resources. This webinar and all other previous webinars are on the Minoxavent YouTube channel. These presentations are linked off of our website, minoxavent.com. Click the Media Center tab and click Webinars. Webinars are usually held the last Friday of each month. Due to the holidays, our December webinar will be Friday the 18th. Our topic will center on Minoxavent's FRP products. We realize all of you have busy schedules, and we genuinely appreciate the time you have spent with us. Thank you.